worries. It's not for everyone. It's not working. So, all right, the MIDI 80, right? My name's Joel. Joel H. See me on the Discord. Down Poly for the music that I do with the machines. So this tech talk's going to be on the MIDI 80. Michael wasn't able to make it, so I'm going to try to cover in his presence. He's the creator of this. He's a programmer. I am not. Full disclosure, I'm not a programmer. So I'll do my best to try to convey the technical information of how this works, how it interfaces with the TRS-80, and how I use it, how it can be used in the studio with music production, the different various ways that it works. So hopefully I don't string this on too long. The MIDI 80. What is the MIDI 80? It's a sound card for the TRS-80 that uses MIDI. It has a wavetable header, just like your typical sound cards of the day, like your Sound Blaster and stuff like that. So you can, any 5-volt wavetable card should work with it so long as it's standardized. It works for the Model 1, the Model 3, and the Model 4. I don't have the Model 1 card showing here. It looks a little different because obviously the bus interface. But yeah, everything I show here is for the Model 3, but everything translates over to the Model 1 just as well. All the software works there as well. It also can be used as a standalone MIDI device. You can actually flip it up, switch dips 3 and 4, and you don't need a computer. As long as you've got a wavetable card installed like I have on these, you can just plug a keyboard directly in, and you can actually just play it. I actually forgot my keyboard of all things, because I don't really use it to play live, but it is used as a creation tool. So I'm actually going to demonstrate one of Michael's other pieces of software, which is using the TRS-80 as a keyboard itself in place of my missing MIDI keyboard, using another MIDI 80, of course. All right, so technical details. Obviously, we've got the 50-pin, but it connects to the 50-pin bus on the Model 1, the 40-pin, I think it's 40-pin bus, I believe. You have LED indicators that give you MIDI in, MIDI out, data in, S2 data out, and MIDI, or data out, yeah. So it gives you MIDI in and data out, MIDI in, MIDI out, data in, data out, and then S2. Obviously with the various switches I'll cover here in a little bit, you can change the scenario how it works. It's obviously based off the STM32 microcontroller. That kind of handles the heavy lifting around here, everything, and I'll go into a little bit more detail on how that works. You add the Adafruit module, you can build these, purchase them online, they're pretty cheap, I think they're like $10 or $9 each. You build those up and then you give yourself MIDI headers. So it uses the Adafruit 5-pin DIN connector, and then it has a little headphones output, so when you do connect a wavetable card, you can get your audio out directly. Again, comes in helpful with the standalone mode. So I'll go into a little bit of the technical architecture here again. Full disclosure, I'm not a programmer, so. But we'll cover the detail of what I have. I've got the 4 main parts of how this works. You've got your MIDI in from the TRS-80, your MIDI out to the Wave Blaster, and then your MIDI out via the headers to your various MIDI different gear. This is kind of like a logical diagram of how it lays out. I've got the TRS-80 bus over here on the left. You only have 3 support chips plus your STM32, so you've got a couple of 74 logic chips and a GAL that he's programmed. The GAL itself basically listens on the bus or when it's listening for MIDI in, and it, actually, no, sorry, take that back, scratch the GAL. So starting with MIDI in, when MIDI data is presented to the device, the microcontroller sets up a 256 byte FIFO. I had that as K, and I was like, yeah, there's a difference there. I was like, yeah, these guys are not going to let that slide. So I would fix that. But yeah, so it's a 256 byte FIFO buffer that it throws data in when it comes in on the MIDI port. When it comes from the TRS-80, it's not necessarily buffered. I think it believes it just yanks it and throws it straight in and it is processed and then pushed right back out. But when data comes in, he has about 4 ISRs, I believe is what they're called. The first one handles the MIDI in and it drops it into the buffer there. When we're dealing with the TRS-80 and getting MIDI data, like when you're using a tracker program, then you go in to start using the support logic chip. He's got a GAL program that listens for port 8 and port 9 calls and requests. When it detects those, it sets everything up with, I believe, the STM32. The 374 and 244s are used to latch to the data and the address buses. So when the GAL actually detects that activity coming in, then it throws it over and all the magic happens, right? So we get a read in from the TRS-80. It uses the other ISR, processes it, dumps it either out, MIDI out, which I have set up here, or you can have it set up for the Wave Blaster. That depends on your 4 settings up there, which I've tried to highlight with a little switch block. And then, yeah, the last one, this one just covers how the standalone mode works, where it doesn't even use anything for the TRS-80. It just simply uses the code on the STM32. Again, you can dump MIDI in and send it either MIDI out to another device, or you can send it to a Wave Blaster card, which is on here. And I think if you want to unmute me real quick, I think I should be sending straight to it. I think I've got it. Yeah, so it's like I'm using the keyboard. It's the octave is set really high. Yeah, so I've pushed myself out of the scale of octave here because I don't use the keyboard part on it really well. But I wanted to show that, yeah, you can use, I'm actually sending from this MIDI 80 to this MIDI 80, MIDI out, back in, MIDI in, and then out of this wavetable card into his audio there. You can mute it. It's good. So that covers how kind of like standalone mode works. Now use cases, the fun part, how I use it, right? So this is the main way that I use this tool. This is probably the best software that he's probably created for this tool, and hands down, compared to everything else. Being able to use the tracker and be able to drive, this is comparable to most tracking sequencers that you use on a computer. But what you're looking at here is the tracker screen. You have 2 rows. It's a full pattern, so 1, 2, 3, 4, 5, 6, 7, 8. You have 6 lanes. Each lane is a MIDI instrument. You have 128 notes, 128 velocity patterns, and then I don't recall the there's instruments, but I think it's 128, or depending on the device you're connected to. I have a device that has over 1,000 instruments. I don't know if the software can cycle through 1,000, but I can cycle through it on my device as well. I believe you could cycle up to 128 or 64 actual instruments per lane. And so you could set up 6 instruments per computer. And so I'll go ahead and demonstrate. I went ahead and put together a pattern, and I'll just go ahead and play it and gonna get an idea of how we get, this is using the Certashop S2 Wave Blaster module. It's like a $40 little Wave Blaster, little 5-volt card. But it produces some really good tones, and as you have listened to some of the music that I've made with the project that I've done, a majority of it has been done with the S2 Wave Blaster. So it's a very versatile little tool, but that just demonstrates, this is a pattern I created. I wish I could turn my machine around, but yeah, it uses pretty much almost all 6 lanes, 6 different instruments. And now I'm just using one card. Stick around tomorrow, you'll see me use this more in a complex setup. And so yeah, I'm using an old tracker version, so it doesn't have a MIDI, panic button. Now we have a panic option to kill it when notes hang. So yeah, that's an example of how the sequencer works. You can put together different patterns, and I didn't have actual screenshots of how we'll build the song. I'll kind of show some of that tomorrow when I have everything set up where you can kind of see the screens a little better. One of the next use cases, as a MIDI controller, as I was showing you before, when you can use these keys and actually just send MIDI data, as I demonstrated before, lighting up and sending sounds, basically using a keyboard. You can plug in just about anything. There are several things that do MIDI sounds. You have these weird boxes that have all sorts of controls and toggles. They also send MIDI data. There's so many different instruments that still incorporate the MIDI standard. So right now I'm using the TRS-80s and a keyboard sometimes when I write, mainly the TRS-80, and I build tracker sequences. But this software allows you to play the keyboard on the TRS-80 like an organ. There's also another one. I don't have the Orchestra 90 plugged in, but it works it's identical, only you get to play the Orchestra 90 now like an actual keyboard instead of having to just program a song in like the software does. So now you can sit there and kind of compose, and if you want to plug in a real keyboard and play the orchestra, you can. So you can play it like a real musical keyboard, which is really neat. Oops, sorry, I slapped myself. So this is how I'm kind of using the orchestra. This kind of just chunks the MIDI 80 completely out of the picture. You'll see more of this tomorrow if you're here. I have just a system that just has the orchestra plugged in, and him and George Phillips have come up with this awesome piece of software that lets you play the orchestra in real time using the computer itself without MIDI, without any kind of control. That is also probably one of the coolest things. I think this and the tracker probably top it as far as the software goes for the MIDI 80. It's all open source, by the way. You can grab it out on GitHub. You can build this stuff. This is all open. He has it all open on GitHub. So. But yeah, this lets you play the keyboard. I'll show. They'll have a better demonstration of this again tomorrow. I wish I could get all my gear set up, but 15 minutes is not a lot of time to get it all going. But yeah, I send the signal out of the orchestra, and I pipe it through basically my pedal board, which kind of gives it a tube preamp, compression, filter, wah, distortion, all sorts of effects, chorus, delay. And then I process it into what we call IR now, which is impulse response, which is even new technology that's taking off past my knowledge of music. Impulse response now is a new way of capturing how a speaker sounds and emulating it on like to 99.99% accuracy, to the point to where you can actually go out and buy IRs of your favorite speaker and load it into your pedal. It's that detailed. It's wild. So that's what I use. I use the Boss IR200, and I basically process it through various different types of amps, bass amps, 2x12 combos, 4x12 combos, or 4x12 stacks. Like, I get to play around with it and I get to play and make different sounds using the computer. So I can get so much sound just even out of the orchestra, not even using the MIDI 80. So yeah, studio gear. So kind of recapping here, right? You have MIDI control, and then you have analog synth. You can use it as a MIDI controller for sequencing songs. You can use it as a MIDI controller for controlling instruments. There's also features that you can use on the software. I haven't used them a whole lot, because my workflow doesn't require them, but they're there for other folks that use them. There's a full complement of being able to load up MIDI data. You can plug in like whatever you're recording, or say you set up a sequencer, you can just dump it straight into the memory of the TRS-80, and it will play it back time accurate, I believe. And so you have that, you have MIDI through. There's also MIDI songs that he's put on here. If you'll keep it muted until I tell you no, because you're gonna get a bunch of computer sounds as it resets. You can actually take your favorite compositions of MIDI songs, and I believe him and the other guy that was testing it has written a tool that you can convert your favorite songs into MIDI songs, and then you can just play them directly from the TRS-80. So let's see. This one should be here. So this is Alf. I don't know the name, the actual song that it starts with. And let's see. If you want to unmute me, this may play fast. I may have to, yeah, okay, hold on. Once some of these programs, so like the tracker, Storch, and some of the other ones have code in them at the front that tell it drop in the system slow. So if you're running on Model 4, some of it should automatically slow itself down, but for the songs, you have to slow the system back down to the 2 megahertz mode, I believe. So let me do that real quick. There we go. All right. So, and this is just Alf. This is a test. This is on the demonstration diskettes if you download them from GitHub. He has them on there just so you can test to make sure. It's a good test to make sure your system's working. So let's see. There we go. A little fast, but it's playing. But yeah, that's a full MIDI, full composed song, I believe. 16 channels, I believe, is what MIDI maxes out at. But yeah. So yeah, so you could play songs. I mean, there's so much musical flow coming out of this device. It's just little device, big impact, honestly. But yeah, so going into some more intricate use cases. This is kind of like what I'm using here. I've only done the first two. I've not yet to expand to the third machine yet, but he has basically put code in the newest version that lets you use the parallel ports of the machines to send sync data, to send the clock pulse that your master tracker is. So you can set up 1, 2, 3 machines with trackers. Each tracker has 6 channels. So you can run 6 MIDI channels to one device, 6 channels to another device, and then 6 channels to, like, obviously there's only 16 max in MIDI when it comes to the application, so you'll have 2 left over. I'm actually working on some other ideas for those other 2 channels. But you can use a synchronization cable, and you can line up all 16 channels to have 3 machines playing. So if you're around tomorrow, I'll have at least the 2 machines set up of this process. One of the ultimate goals I'm trying to get to is the super orchestra. So I'm pretty close. It's 11 machines, 1, 2, 3, plus 8. Yeah, so I think I've got 11 machines working. I don't know. I think I may have to tap into one because I think it was dead when I pulled it off the shelf. I've already bought all the orchestras, so I have those. I have the hardware for the MIDI 80s. I've got 4 built. I thought I was going to be a champ and try to build all 8 in one night. Yeah, I'm not that good. So I've got 4 more to build. I think plus the 2 that I bought from Michael himself. I'll probably have to get 1 more to complete the project, but this is kind of the end goal of my project, or what I'm trying to do with the music. And these tools, it's perfectly capable of doing this. What's happening here is this master will use MIDI to drive the 8 other MIDI 80s who will be attached to the orchestras. This master will have 6 of the 8, and then the other 2 will be attached to the second system. But between these 2 systems, they'll share patterns that will drive all of the orchestra cards as if they were a fully polyphonic, or at least 8 polyphonic keyboard. As of right now, you can only do 1 or 2 notes at a time. So 2 notes max, 1 note from each row. But being able to drive it with a computer, so much more capable. And yeah, so this is the goal that I'm going for. You'll have drums, a little bit of background music to kind of sampling and all that other fun stuff to go with it. But yeah, basically a 8-channel synth organ created using the orchestra. But yeah, future goals, right? So yeah, that's all I've got. I wanted to make sure the credits are up there. We got Michael Wessel for creating the MIDI 80 and doing the firmware, George Phillips for helping him out, creating storage. And then we got beta testing, Jurgen, I think is that how you say his name? I'm terrible at pronouncing it. And then obviously me. But yeah, questions.
What's your electric bill?
What is our electric? It's pretty good, right? Keep things. What is my electric bill?
It's all right.
Yeah, you keep it there. All right. I do turn things off.
So we have a lot of AC, so that.
Yep. And with it being storm season, yeah, I don't like to leave things plugged in. I don't like coming back to a dead box. Any other questions on this? Like I said, I'll have more interesting stuff set up tomorrow when I get the full gear going. You guys can see the screens and all the real jazz. But yeah, that's the MIDI 80. If you want it, it's out online, free to build.
Will it sync to a digital audio workstation?
He's working on that. That is a good question. The synchronization codes that flow with the MIDI data is a little bit too much overhead for the TRS-80. I don't know if Michael plans to work on that or not, but that's why this cable came in handy, is it helps at least get sync across from one machine to another. But yeah, getting into the DAW would be extra helpful because yes, when I am creating on here, there is a little bit of a bridge gap where I have to sit down and manually plot out tempo paths so I can, because when you record a song in a DAW, you want your song to line up with like the tempo. So if you go to do edits and you snip something out, it makes it super easy to snip out a mistake and put in another one, like easy peasy. Simple stuff like that. So I try to lock songs to a tempo, and when it comes to that, yeah, it comes to it. His question was, does it have the option to sync to a modern DAW? And that's dealing with like MIDI sync and time codes that come across the MIDI channel, and that's not yet. I hope Michael goes to improve it, but if not, I'm happy with what I've got right here because I can do it, and then lining it up manually just takes a little bit of time, but it works. It's again, it's a computer, so it stays in pretty lock sync. Any other questions?
Yeah, for the parallel port synchronization, do you have a practical limit on the number of stations or the distance you could go before you start running into problems with that synchronization system?
That is a good question as well. So his ask was, is there a practical limit on how many stations that we can jump? I believe his max is 3. I have not tried it yet. I plan to do the 3 machines, and then I want to grab the pulse off the end of that and feed it to my pedal board and then experiment to see if one of my pedals can take in that pulse. But yeah, as of right now, I believe it's limited to 3 machines. But I don't see why you couldn't take it, because you're basically taking pins 1 and 3, and then going for, pins 2 and 3, and then 2 to like 21 or 23. And then you'll just take this same signal, go to the next machine, go to the next machine. They're all going to follow the master clock. It's really neat. It really is neat to see a 3 fly as fast as a 4 can. Because when you do, it's like you're turning this guy's clock off, and he's following the 4. So that's really cool. Any questions? Any other ones? Nope. Cool. Well, hopefully this has been informative. Hope you guys enjoyed it.